Hi guys, welcome back. So in this video I'm going to discuss a interview problem, that is counting bits, and this question has been asked in past interviews. So it is an interesting problem which involves a use of dynamic programming and a bit basic concepts of bit masking. So the question says that we have a number n given to us. Now we need to return an array which contains the number of set bits inside all the numbers from 0 to n. So let's say I have been given 3 as n. So I have to return the number of set bits in 0, number of set bits in 1, number of set bits in 2, number of set bits in 3. So I will return an array consisting four numbers 0, 1, 1 and 2. Now if I have a number, let's say m, and it has k bits inside it, then it would take me k iterations to find the number of set bits. So if I consider that there are k bits on an average from all the numbers 0 to n, then it might take me k star n iterations to find the number of bits inside every number from 0 to n. So it has been given in the question that we need to find this result in O of n time. So it has been clearly mentioned that you cannot use the built-in functions and you cannot find the binary representation directly, and to binary representation to iterate on that and count the number of set bits. So we are going to use the concept of dynamic programming and some basic concepts of bit masking. So let me give you an intuition for dynamic programming first. Now let's say we are considering a number 10. Now if you want to find the binary representation for this number, then it would be 1010. So what I'm going to use is that if we take a right shift of this number by 1, then we would get representation as 101, that is 5. So if our DP array stores the number of set bits inside this number, then we can at least find the number of set bits inside this part of the number and the set bits inside the remaining one bit can be found using taking AND with 1. So if this comes out as 0, then there is no set bit at last position, or if this gives 1, then there is one bit is present at the last position of the binary representation. So this is the basic intuition which you might need to solve this question. So if you have understood the concept, then try coding out this question, and else I am also explaining how we are going to apply the bottom-up approach. So let's say I am considering n as 6, so I need to find the number of set bits inside 0, 1, 2, 3, 4, 5, 6. So this is 0, 1, 2, 3, 4, 5 and 6. Now I am initializing the number of set bits of 0 as 0. Now to find the number of set bits inside 1, I will take a right shift first, and this is my DP array which I am going to return. So I am going to check inside DP of 1, right shift 1, the value stored as 0, as 1 right shift 1 is 0 plus 1 and 1. So this will give me 1. So for DP of 1, I am going to store 1. Now similarly for DP of 2, I find the value stored at right shift of 2 by 1 and adding the value of 2 and 1. So binary representation of 2 is equals to 1 0, and if we take AND with 1, it would give me 0. And dp of 2 right shift 1, that is dp of 1, as right shift of 2 would give me 1, so dp of 1 is 1, and this value comes out to be 0, so I'm going to store 1. Now moving on to the next number, that is 3. We'll take out the number which would come after taking right shift of 3 by 1, and we will also take AND to find the last bit of the number 3. So 3 can be represented as 1 1, and if we take a right shift, we would have a number 1. So first of all, we need to find the value of dp of 1, so that is 1, plus if we want to take AND with 1, it would give me 1, so this would be equals to 2. Now if we carry on doing this for 4, this would come out to be as 1 0 0 and 1 plus dp of 2, as right shift of 4 would give 2, so dp of 2 is 1, and 4 and 1 is 1. Sorry, 4 and 1 is 0, so this would give me 1. For 5, if we take a right shift, we would have 1 0, that is equals to 2, and if we take AND with 1, it would give me 1, so it would be equal to dp of 2 plus 1. So dp of 2 is equals to 1 plus 1, that would give me 2. Now for value 6, I have to calculate 6 right shift 1 and 6 and 1. So dp 6 right shift 1 would give me, first of all, 6 can be written as 1 1 0. Now if you want to find the right shift, it would give me 1 1, that is equals to 3. So first of all, I need to add dp of 3, that is 2, plus I want to calculate the value given by 6 and 1, so it would give me 0, so this would come out as 2. So let's verify it now. We have elements as 0 1 2 3 4 5 and 6. Their binary representations are 0 0 1 1 0 1 1 1 0 0 1 0 1 and 1 1 0. So the number of set bits in 0 are 0, in 1 it is 1, in 2 it is 1, in 3 there are 2 set bits, in 4 there is only 1 set bit, in 5 there are 2 set bits, and in 6 there are 2 set bits. So earlier we found the number of set bits using the concept of dynamic programming and bit masking, and the values are matching, so we have applied a correct concept, and we have managed to solve this question in O of n time complexity. We have not iterated on the binary representation of any number, so we have just used the AND operator and dynamic programming to solve this question. So we have optimized it according to the constraints given to us in the question. I hope you guys like this video. Thank you guys.